Hello guys, welcome to IB360. So today we will talk about oxidation and reduction. So this will be basically the next topic in cell metabolism. The first topic was enzymes. We have already covered that. So oxidation and reduction, these are reactions, metabolic reactions which takes place inside our biological system, also in the environment always. But how is it affecting the biology of our body, of living systems body, that we will see. So basically oxidation and reduction can be defined in terms of addition or removal of oxygen, hydrogen, that means addition or removal of hydrogen, or in terms of gain or loss of electrons. So if a substance is losing oxygen, it is supposed to get reduced, and if it is gaining oxygen, it is supposed to get oxidized. Similarly, if a substance is losing hydrogen, it is supposed to get oxidized, and if it is gaining hydrogen, that would be reduction. For electrons, you can remember it by oil rig, where this stands for oxidation is loss, oxidation is loss of electrons, and RIG, reduction, is gain of electrons. So by this you can remember how electrons, in terms of gain or loss of electrons, we can define oxidation and reduction. So reduction process is just the opposite of the oxidation process. It is essential to know that both of these processes cannot occur alone. So what I'm trying to say is, if one substrate or if one of the reactant is losing oxygen and getting reduced in the process, it must lose oxygen to some other reactant. So the other reactant which will take away its oxygen, which will gain oxygen in turn, gets oxidized. So both reduction and oxidation processes are occurring hand in hand. See, here also it is mentioned substance which loses oxygen, there must be another substance that gains oxygen. Similarly, if a substance loses hydrogen, just a second. Similarly, if a substance loses hydrogen, there must be another substance that gains hydrogen. So that proves that these two processes, reduction and oxidation, cannot occur alone. They must occur at the same time, simultaneously. So thus it is clear that if one substance is oxidized, it must reduce the other substance. It shows that both oxidation and reduction always go side by side. For this reason, these reactions are called redox reactions. In the word redox, the word RED refers to reduction and OX refers to oxidation. As simple as that. Okay. So reduction as well as oxidation taking place simultaneously, that would be redox reactions. And in nature, always reactions are redox. They are not solely oxidation reactions or solely reduction reactions. Okay. So here are some examples of oxidation and reduction reactions. In the first case, you see we have copper and oxygen as the reactants. So copper is in solid form, oxygen is in gaseous form. Copper is reacting with oxygen, forming copper oxide, which is powdered in nature, reddish brown colored powder. So copper is getting oxidized because it is gaining oxygen. So this is gaining oxygen, that means oxidation. In the second example, we see there is copper oxide and there is hydrogen. Copper oxide, again the reddish brown colored powder, and hydrogen in its gaseous form. And the products would be copper in solid and water in liquid form. So here what happens, copper oxide is losing its oxygen to water. So copper oxide turns to copper element. From here we get this. So what would be this process? This part where copper oxide is turning into copper. See here we see there is loss of oxygen, so this would be reduction because copper oxide is losing oxygen, loss of oxygen. But the other part of the reaction where hydrogen is getting converted to water, hydrogen is gaining oxygen, so this would be oxidation. Oxidation of hydrogen to water. Gain of oxygen. Okay. So the reaction between hydrogen and copper oxide, copper reacts with hydrogen, produces reddish brown copper and water vapor. In this reaction, so this is gaseous form, not liquid form actually. In this reaction, copper oxide loses oxygen and gets reduced to reddish brown copper, whereas hydrogen gains oxygen to form water. In other words, copper oxide has been reduced to copper. See reduction by losing oxygen molecules, whereas hydrogen has been oxidized to water by gaining oxygen molecules. So this is oxidation. Actually, in real life also there are so many processes, like rusting is an example of oxidation. Then rancidity. Then corrosion. Outside biological system, all these processes are there which are examples of redox reactions. Then we will talk about oxidizing agents and reducing agents. So here the definition is a little bit complex. By oxidizing agents, you can understand this concept in such a manner that oxidizing agents help in oxidation of the other reactant. Here the other reactant is important. It doesn't itself gets oxidized, rather it helps in oxidation of the other reactant. Similarly, reducing agents help in reduction of the other reactant. Here we have example, very nice example again. We have hydrogen sulfide, and hydrogen sulfide is reacting with chlorine gas and forming hydrogen chloride and sulfur. So this is not hydrochloric acid because in gaseous form we have hydrogen chloride and we have sulfur as a solid. So sulfur is getting oxidized because it is losing hydrogen. You see here, it is losing hydrogen. So there is loss of hydrogen and hence oxidation. And chlorine on the other hand is accepting hydrogen. There is hydrogen transfer and this is reduction because gain of hydrogen. So here chlorine is helping in oxidizing sulfur by accepting hydrogen. So it is itself taking the risk and saving the life of someone else, something like this. So here chlorine is our oxidizing agent, OA. Here oxidizing agent is chlorine because chlorine is accepting hydrogen, gaining hydrogen, and in turn helping in the oxidation of H2S to S, hydrogen sulfide to sulfur. So since it is helping in oxidation of the other reactant, it is the oxidizing agent. Similarly, hydrogen sulfide is helping in reducing chlorine, so it is acting as a reducing agent, RA, because it is helping in reducing chlorine to HCl. It is itself getting oxidized but helping in reduction of the other reactant. So this is the idea. This is the idea of oxidation and reduction. Thanks.